Hey everybody, we're going to write an equation for a quadratic function when given 2 points. So we're given the vertex, and that's important. It has to be a vertex point, not just any point on the parabola. So we need to have the vertex point. Remember that vertex point is that point at either at the very bottom, which is called a minimum, or it's that point at the very top, which is called a maximum. And then we're given another point on the parabola, any other point. So any other point. So vertex point and any other point on the parabola. What we're going to do is we're going to take these two pieces of information and we're going to write an equation for the graph in vertex form. So remember, vertex form looks like this. That's vertex form. And the point, the vertex, is the h value, which remember that's your translation left or right, and your k value, which is your translation up and down. So that represents your vertex. Now x and y, that's going to represent any point on the graph. Okay, any point on the graph. So we're going to go ahead and plug in our information. So this is going to be our h, this is going to be our k, because this is the vertex. This is going to be our any point right here, so this is going to go in for x, and this is going to go in for y. So let's plug this information in. So y is 9. We do not know a. X is -1. H is 3. And k in this case is 1. So this is what you need to do. When given a vertex and given a point, you need to plug them into the vertex form, and what we need to do is solve for a. Okay? So solving for a, we're going to go ahead and start inside the parentheses. So -1 minus 3, -4, -4 squared, 16. Okay, so we simplified first. Now we're going to solve for a. Remember that this is a times 16, so to undo multiplication, we divide. So we have a equals, and this reduces down to 1/2. So now we can write the equation of this graph, this parabola, just by having the vertex form and a point. So we're going to write it like this. Y equals, a is 1/2, x minus h plus 1. And there's vertex form. Now let's translate that to standard form. So remember, it's called vertex form because it tells us the vertex. Since the a value is positive, we know that this one's going to open up. Okay, and it's got a vertical compression because the a value is less than 1. All right, standard form. To do standard form, we want to take our vertex form and we want to, first of all, expand this out. So we're going to have y equals, when you square a number, it means to multiply times itself. So when you square a group, you're going to multiply the group times itself. So, you know, there's different paths you can take from here, but what I'm going to do is I'm going to FOIL This is all multiplication. So I'm going to go ahead and FOIL these two groups. A binomial times a binomial. So first terms, inner, outer, last. Now, please note, when I multiplied these together, I left them inside a grouping symbol. The reason being is because I'm multiplying the 1/2 times this group. Okay, so let's go ahead and simplify the group, combining our like terms. Now what we're going to do next, we're going to go ahead and distribute the 1/2. Using the distributive property. Okay, and now we're going to go ahead and combine any like terms to simplify this down. So notice we have our vertical compression. It's opening up because it's positive. So that's one thing that standard form and vertex form have in common. They both tell you the A value. 9/2 plus 2, plus 1, 2, which 2 over 2 is the same as 1. The reason I made it 2 over 2 is because we have a common denominator then. So 9 plus 2 is 11, and the denominator stays the same. So again, I made the 1 into 2 over 2 in order to add my fractions together. Numerator plus numerator, denominator stays the same. Okay, and we all know that this is 5.5, so you could write 5.5 here. Now, what does that number represent on the end? Each form tells us something a little different about the graph. The number on the end, the C value, represents the y-intercept, 5.5, and we would write it like this. Okay, and that's how we do these problems. Hope you guys are having a good night.